Hey, how's it going? Really excited to be here and talk about the Nest API. It's a long time coming. How many of you guys signed up to hear about this probably about 8 months ago at this point? Exactly. Waiting for a long time. I'm really glad to be able to talk about it now. We've been working on it for about a year, and I think we have fully thought through this, kind of built an entire comprehensive program, and we're going to talk through quite a bit of it today. So things we're going to go over. We're going to go over kind of details of the API, kind of high level what the features are, and also go through some examples as to how to build to it. Mark's actually going to walk through some sample code. Design, some design guidelines, as well as some kind of tips of the trade of things we've learned over the last couple of years, and some details on how you should test and how we are going to test your apps. So where did this all begin? It began in a garage. So we started in a garage about 3 years ago. In Palo Alto, off Olive Street, and this is back in the day when hardware was dead. Like no one was going to build anything in hardware. No one was going to fund anything in hardware. And in fact, I think the story was that the days of the hardware startup were long over. But we've grown, and we've built a business. We've grown considerably since we started three and a half years ago. And we have a whole campus now. So like, if you're down in Palo Alto, there are 3 Nest buildings, and actually we've totally filled them up now. It started with a thermostat, and people laughed once upon a time. Like, can you build a company reinventing a thermostat? It turns out you can, and you could do really well doing it. It started with the idea of, can we reinvent these unloved categories? Can we bring design, technology, connectivity, learning to a category that has none of that? And it's really exciting to see that there's an entire industry now around reinventing these unloved things in the home. I can imagine, actually, how many of you guys are interested in building products for the home? So that's amazing. So if I had asked that question 4 years ago, like probably 3 hands would have gone up. So that's amazing. Like, an industry has been created now, and I think we're at a really good place to work together on this. I think with Nest critical mass and your brains, I think we could build some really cool stuff. So taking the thermostat and Nest Protect, about a year ago we decided we really need to do an API. We're hearing from you guys. We're hearing that it's time to do it. There's a untapped set of products that we can never go build. Like, Nest can only do so many things on our own. Yes, Nest will continue to build great products, and we've got a ton in development right now. I'm really excited to share soon. But as you can imagine, there's a lot we could do with just what we have today. So what is the Nest API all about? So one, of course, it's about controlling thermostats and things like temperature control, home comfort. And there's a lot of things that we've done so far with home comfort, and we've added features continuously since we launched the company, but there's a lot more we could do, and things that I hope that people will go pick up. Protect events. So we launched Nest Protect last fall, and it's really about safety. And this is a brand new category for us, and things we've thought a lot about. And I think for this first generation of APIs, being able to listen to Nest Protect events and figuring out other things you could do with those events. So I don't know if you guys saw some of the examples that we've launched, but these guys, LIFX, who've built a connected LED light bulb, listen to Nest Protect events and flash the lights red when there's an alarm in the house. I think it makes a lot of sense. I'm curious what other kind of things we're going to come up with this API. Home and away, extremely powerful. And this is something that we've taken years to develop, kind of automation around home and away, where people don't have to go and push a button to do it. So being able to listen to those events and know when people are gone from the home automatically, as well as with the user's input saying, hey, I'm gone, things can happen in my house now that I'm away, and when I'm coming home, do something for me. ETA, so picking back on home and away, but actually providing some input. So a really popular example that we've heard from users and that we've launched now with the API is, hey, I'm driving home. Why can't my house know that? So we partnered with Mercedes-Benz. They were kind of an early beta of the API, and what they've done is super cool. So as you're driving home, the car tells Nest, hey, Matt's on his way home. He'll be there in 30 minutes. Make the house comfortable for him. It's super cool. So it's all about the home. And everything about Nest is about the home. Like, yes, we get a lot of spillover. People use our products in light commercial and small businesses and restaurants and shops. But most of this program is about the home. And most of what we do is about the home. So we've built an entire program around revolutionizing the home. So kind of some high-level details of the program. So all of the information is on developer.nest.com. very, very detailed specs. So we've had an entire team working behind the scenes for the last 4 months, documenting the APIs, building sample code, going through examples, really getting into the details so that you can pick it up and just go. We're available. We actually have an entire developer support team behind the scenes now, ready to answer questions. And we've actually put something up on Stack Overflow for people to ask questions to us, and we'll answer. But we put a lot of resources on developer.nest.com for people to learn more. We're working with anybody. So not just large companies like Whirlpool and Mercedes-Benz, but small developers too. Individuals who have an idea, who want to get started. We work with everybody. And we've designed the program to be extremely cross-platform. So any connected product, be it a hardware product, iOS, Android, the web, a pure service, the Nest API should work with everything. And we've kind of designed it to be extremely cross-platform. Like to the point of not just cross-platform, but cross-product and cross-industry. So here's some examples of some of the early partners who have been working with us behind the scenes on the beta to make sure this program is rock solid. For the last 4 months, these guys have been working with us behind the scenes, and I think what they've done is really cool. How many of you guys were able to check out some of the demos? We had an event on Tuesday. Anyone check out the demos? No? A couple of you guys? We put together a video that I'll go through in a bit, kind of explaining what some of these integrations we're able to do. Super cool stuff, and things that we could never have done alone. So we have lots of ideas. You guys do too. I'm really curious when we put our ideas together what we'll be able to do. So completely cross-platform, companies big and small, and also no hardware changes required. Like any internet-connected product should be able to work with Nest. I think this is a really important thing. And you may have heard about other home ecosystem platforms that are emerging, like something from the fruit company down the street. You may imagine that some of these things are light on details, but I can imagine it's not going to work with any hardware out of the box today. And I think this is really important for especially products that exist today. So with a software update, you should be able to work with Nest. And I think that's really important. It's also open today. So unlike other products down the street, you could go and work with Nest today. You don't need to wait. So Nest is in 3 countries today, US, Canada, and UK. We're expanding rapidly, and this program will expand with us. So we expect that as Nest expands, and will expand throughout Europe, throughout Asia, throughout the rest of the world, the Nest developer program will go with us. And we'll establish developer communities throughout countries as we go. It's an incredibly comprehensive program. I think we've thought it through end to end. So it's not just about the APIs and the documentation. It's about marketing and about logo assets. So you could put things on your box or on your website to say you work with Nest. It's about having resources that are behind the scenes to help you build your ecosystem. And also, I don't know if you guys saw that we announced a fund with some of Nest early investors that I'll talk about in a bit to help small companies get started in this industry. And we will work with everything from apps to connected appliances to connected coffee cups. And I'm sure some of you guys are probably working on connected coffee cups right now. We will work with everything, and we're really excited to see what those products could do.
All around the world, the home is the center of people's lives. It's where you start your day and end your day. It's where you raise a family and make memories with the people you love. So wouldn't it be cool if our homes could be more aware? If our homes could learn from us and help take care of us? At Nest, we do just that. It all started with the Nest Learning Thermostat. Then came Nest Protect. But for us, that was just the beginning. Our goal has always been to bring this kind of thoughtfulness to the rest of your life. That's what Works with Nest is all about. Works with Nest makes it possible for your Nest thermostat and smoke alarm to interact with the things you use every day. Because we make connections between these different parts of your life, we can deliver personalized comfort, safety, and energy savings without you having to do a bunch of work. We've been working with companies big and small to make this a reality, and we're very excited about what we've been able to do.
Up is a combination of a band that you wear around your wrist and an application on the phone that together help track your movement throughout the day. By connecting your Up and your Nest, you can have this complete effortless experience. Because Up's right on the body, we have this rich contextual set of information about what the person's doing in the moment. And so that means those days that you might wake up a little bit earlier, before you even get out of bed, we can let Nest know that, so it can then adjust the temperature in the room to start to be for my daytime. This is about technology not for technology's sake, but technology in service of a better life, helping us be more human, allowing us to live our lives better.
Why would we ever bring the thermostat and washer together? That's a good question. If you look at it from a perspective of energy consumption, it's an easy one. These are the big energy consumptions at the home, and they're also the ones which require a lot of day-to-day interaction with the consumer. If you have already the thermostat communicating to the utility company, it's much easier if there's one signal going to the Nest, and that is disseminated through the household to all appliances to basically reduce consumption now because we're at the peak. It's just a tremendous consumer benefit, it just happens in the background.
LIFX is a LED light bulb that you control with your smartphone. When we first heard about the Nest Developer Program, we were really excited to be a part of it. With Nest Protect and LIFX, when a smoke alarm event is triggered, we can pulse your lights red, which can help you see in the dark, as well as give extra notification that there's a problem in the house, which is especially good if you're hearing impaired. Nest brings this whole other dimension to LIFX. Who would have thought by combining Nest products and LIFX products we could help save lives?
Automotive industry is in a very deep change. I foresee that in the next 10 years, the changes are going to be more substantial than in the last 50. Likely your car today interfaces with your home through the garage door opener. After learning about the Nest Developer Program, we thought about, how can we take this to the next level? How can we, integrate the car better with your home? As you get into your car and drive home, the car will, in the background, send the estimated time of arrival to your Nest thermostat. So your home can be at the right temperature as you arrive at home. Taking workload off of customers, it will improve safety, it will increase comfort, because people just don't have to think about all these things. It's just great, like magic in the background.
At Nest, we believe these experiences are the future. We're able to connect things inside and outside your home to better anticipate your needs. We're already doing some pretty incredible things, but this is just the beginning, and we can't wait to see what's next.
Pretty cool stuff, right? So you can see what we mean by building out the conscious home. It's not just about building connectivity. It's not about just building products that connect to each other. It's about building experiences. And if some of these early partners can show, there's some amazing things that we could build. So I'd like to invite up Mark McBride. So Mark McBride leads the development team that actually built the Works with Nest program. And he's going to talk to you about some of the examples and how to build apps.
Oops, clicker. Hello, thanks for coming. As Matt said, we're going to talk about some of the specifics around the API. We'll talk about how we're authenticating users and protecting user information, walk through some sample code, talk about some UI guidelines, and talk about some of the testing tools we built to make putting together client applications super easy. As Matt covered, right now, Nest sells thermostats and smart smoke and CO detectors. And these two things have a primary function that they execute in the home. The smoke detectors monitoring your environment for smoke and CO and setting off alarms. The thermostat's doing the same with the actual environment and controlling HVAC systems. But given the sensors they have, there's secondary functions they can perform as well. And we use that to determine things about the home itself. So our data is not just device-specific, but it's also home-specific. The other thing that we thought about when we were building out this program is you're not always at home. When you're outside the home right now, Nest has some capabilities, but our partners can offer us a lot more. And so we built the ETA API as something totally new that allows partners to tell us when they're coming home. We'll talk about some of the specific devices now. The thermostat has about what you'd expect from an HVAC control system. You can monitor current environment of the house that it's in. You get access to target temperature controls, to HVAC modes. You can operate the fan if one's in there, and all the things you'd expect from a regular thermostat control. What's interesting about HVAC systems is they're surprisingly complicated. You'll notice in the API documentation that current temperature is not a writable field. That one's read-only. Target temperature is writable. There's a variety of systems that we operate to make sure the target temperatures are achieved. There's emergency heat, there's multi-stage compressors, there's heat pumps, there's radiant heating. All of those things work together to make your home comfortable, but there's things you can do to them to put them in situations that are pretty nonsensical. It's a lot of power, it's a lot of responsibility. Where possible, we're trying to absorb that responsibility. So our API has safeguards built in. If you try to put the environment in a state that doesn't make sense, you'll get an error. We won't let you do something dangerous to the home. So when you're building these integrations, just watch out for things that come back that say, you're not allowed to do this. There's usually a textual description that you can interpret and make sure you don't do that again. Also with the thermostat, we realized about 1.5 years, 2 years ago that we had access to a device that controls the largest energy consumption source in the house. So we partnered with energy programs, utilities around the country to provide what's called rush hour rewards. On hot days, usually, when there's going to be peak demand on the grid, an energy company can tell us we would like some load shed between certain hours so that we don't have to start up coal-burning, usually dirty power plants to meet peak demand. We've made this available to our partners too, because while HVAC's the largest energy consumer, it's not the only one. And we'll talk about some demos and some integrations our partners have done around that a little bit later. The Protect right now is pretty simple. This has alarm states, it has battery level states, and it also has an overall device state. So in our UI, we paint the smoke detector a single color. We don't have lights for smoke and CO and battery. Rather than have all of our clients try to interpret those 3 different alert levels and try to come up with the right color, we have an additional field that's overall device state that you can use to keep your UIs in sync with ours. We don't have a lot of constraints around how you use our data, but in particular with Nest Protect, it's a safety device. And when users are looking at data from this device, it's likely an emergency, and we don't want people to be confused. So we do ask that the alert levels provided by the API are the ones you use in your client applications. Don't try to reinterpret these as, get up, get out, et cetera. Just use the text we have in there. So we talked about the primary and secondary device functions we have. The most prevalent, or probably the most used one we have right now is what's called home and away. So we have PIR sensors, or motion detectors, on the thermostat and on the smoke detector. And using those, we can make pretty good guesses about whether somebody's in the house or not. So our structure has a field that's called away. There's 2 different subdivisions of this. There's manual away and auto away. Manual is exactly what you'd think. The users explicitly said, I'm home or I'm away. We won't use sensor data to override any of those states. The user said what it is. We take their word for it. There's another state called auto away. And if this is enabled on devices, if we don't sense motion for a certain period of time, we put the house into auto away. And the difference between that and manual away is when we do sense motion, we take the structure out of away and put it back into home. Currently, we use this to control temperature. If people aren't in the house, we have secondary target temperatures that are usually more efficient but less comfortable, and we'll revert to those settings until somebody comes back to the house. You can use that for a wide range of things, turning off the lights when people leave, turning on lights when people get home. But we do ask that you respect kind of manual away versus auto away. Auto away is an algorithm that we've built and we put a lot of work into. So while we're giving you the capability to set home and away explicitly, we ask that you do that at the specific request of the user, not to try to duplicate a secondary auto away algorithm outside of Nests. So we talked about ETA. And this is something that's brand new for the developer program. The ETA API is effectively a stream of arrival time estimates that come from a partner. So this makes a lot of sense in the context of automotive. You have a nav system, you have a waypoint. If that waypoint is the home, you have a stream of estimated arrival times that come from GPS, et cetera. You keep giving us streams. We evaluate that stream for confidence levels. If people veer off course, they stop for gas, they have something else to do, we want you to keep streaming us those so that we can take action when it's appropriate. When we trust that somebody is going to be home at a specific time, we'll take appropriate action, make sure the home's comfortable when people arrive. And this is an indication. As the car moves closer to the house, we want arrival times to continue to be streamed. Once we see that it's in range and we trust the estimate, we'll take action to take the house out of the way. So we've talked about the APIs we're providing. Let's talk a little bit about how we're protecting user data and making sure that all of this stuff is secure. The data we're providing is pretty personal stuff. It tells you whether you're home or away. It tells you what temperature it is in the house, whether there's alarm states. We're using industry standard OAuth 2 for communication. Everything's over SSL. There's no opportunity to do clear text. Every user that's exposing data has to explicitly do so with a fine-grained set of permissions. So as a client, you can't get access to all the data unless you explicitly say, my client needs access to all the data. You can instead ask for, I need to read thermostat control data, which gives the user a more comfortable feeling that you're not asking for away states, you're not asking for alarm states. All you really want to do is look at temperature data. In addition to the standard OAuth 2 mechanisms for this, we're also requiring developers to provide justifications for each scope they need. So in the case of Whirlpool, who needs access to rush hour rewards events, they would say something like, we would like this data so that we can put the washers and dryers into a more efficient mode during rush hour rewards events. We're also providing a very high level of transparency to what clients are doing to users' accounts. And so in our energy view, we will decorate all modifications that clients make to target temperatures to home and away with the client application name. So if my Mercedes sets an ETA on a home, when we pull the structure out of away, it will say done by Mercedes drive style. And this gives users great visibility into which clients are integrated, because sometimes people forget, and what they're actually doing to the account. For integrations that are more passive, we also have an activity log per client. So users at any time can go to settings in their application, see all the integrated clients, and see the last time they connected to the Nest service. So here we're going to walk through the typical sign-up flow. If people have used OAuth before, this should look incredibly familiar. Here we're starting from a Whirlpool Smart app, or an illustration of the app. This will say something on the Whirlpool side. Would you like to connect your Whirlpool devices with Works with Nest? Here's the awesome stuff you're going to get once you connect. This takes us to the Nest site, where you see that Whirlpool would like to see the temperature and settings on your thermostat. And the light gray text underneath is text provided by Whirlpool to justify why they need access to this data. Let's scroll through all that. If the user says yes, we authenticate them, make sure that this user actually has permission to expose that data. And then it will return you to the Whirlpool app, which has settings for that specific integration. So that's how we secure data. We'll talk a little bit about the mechanics of actually getting to the data. We wanted this to be real time. And this was something that we talked about internally quite a bit. The easy way to do most of these APIs is typical REST. RPC, connect to the service, tell me information about the thermostat, I'll do some stuff with it. But that's not what we do for our applications. If you look at the Nest applications, when you change target temperature on a mobile device and watch the thermostat, that interaction takes place in less than a second. And in fact, customers call support when it takes longer. So we can see service degradation through customer support calls, because they'll call up and say, hey, it took me 20 seconds. For the thermostat, it's a convenience. For the smoke detector, it's not so much a convenience. It's more a critical safety feature. When the smoke detector goes off, we want to be able to relay that information as quickly as we can to all the integrations around the house. It would be a little weird in the LIFX integration example if your smoke detector went off and 30 seconds later, when the polling hit, the light started blinking red. So we wanted to provide this capability to our client developers. But real-time APIs are usually harder. And we didn't want to do it at the expense of having everybody have to learn a new complicated network programming model that was going to have a steep learning curve and be fragile at best on both sides. So we looked around, and Firebase happened to be doing something almost exactly like what we do for our clients. And we thought it would be a great opportunity for us to work with fairly standard, open, documented, well-supported clients that we didn't have to deliver ourselves. In cases where Firebase clients don't work, we do provide a REST interface. We also provide an event source-based interface. So you can still be real-time if you're willing to adopt a slightly more complicated programming model. This gives us the capability to work almost anywhere. If you can use SSL, you can use our API. And so this is the picture we have today. Typical clients developed with Firebase talk to Firebase servers. With the Nest developer program, you use the same Firebase clients on iOS, Java, JavaScript. You just talk to Nest servers. All right. So we'll go through some example code, and this is pulled from some of the early people we worked with to flesh out the API. And so some of the use cases you saw in the video, we'll go through sample code to show how you could implement that yourself. I will preface this by saying I'm like the world's leading authority on not being good at JavaScript, so don't judge this so harshly on style. But I think it's indicative of what people can do with a little bit of spare time and access to the Nest developer program. So Whirlpool. Large appliances, large energy consumption, listening to rush hour rewards events, putting things into a more energy efficient mode when peak periods hit. Most of our samples start off like this. I make a connection to the Nest Developer API using a Firebase client, and I authenticate with the token that's been provided by the user. We use this ref.on to set up a listener for changes to data at a location. So you see in this case, we've connected not just to the Developer API root API, but we've actually connected to a specific structure that user owns. Here, we say, get me the peak period start and end times, get the current date, and then just compare times. If we're in a peak period, I log to the console, it's a peak period. You do something amazing to remove energy from the grid. If the peak period is not in effect, we just log that it's not in effect. So it's pretty straightforward. Mercedes, different use case with the ETA API. In this case, we have a car going home. Something on the in-dash system pops up, says 30 minutes from home. We say heat it up, confirm, and then the thermostat takes appropriate action. Preheating. So this example is a little bit more complicated because, like I said, we have to send this stream of ETA times. So it's not just going to be a one-shot go through set a value, but we'll try and walk through it. Same thing. We connect to Firebase. Here, once again, we're connecting to a structure and authenticating. We have people set a unique trip ID because multiple people may be coming home to the same house. So we want a unique set of arrival streams so we can take the house out of the way at the appropriate time. We're going to set up a function here that takes an array of estimated times of arrival, pop the first element off the list, create an estimated time that that person is going to arrive. This is an array of ints minutes from now. Then we take a child value of the structure called ETA, and we set a value with the trip ID as the unique one we calculated, and the arrival window begin and end to the same estimate time. We do allow the flexibility to have a window of arrival time in case you're not sure. In the case of a car nav system, they don't provide much delta on either side. And then we just set up a timeout in JavaScript to set the ETA for the rest of the array. And so this is just call it self-recursively, popping elements off the list every minute to set arrival times. And then we just call the whole thing with a simulated set of arrival time streams. A little more complicated, but not crazy. Jawbone's use case is pretty straightforward as well. The wristbands know when you go to sleep, they know when you wake up. With Nest devices, we have motion sensors around the house, but typically not in the bedroom in a real-time capacity. So this allows you to get better presence information or activity information into the Nest API. So the comfort of your home can be set earlier than it would be if you just walked by the thermostat. So in this case, we sense motion on the Jawbone wristband. That makes a call to the Nest service and sets a target temperature. So let's walk through this. This should look very familiar by this point. Connect to Firebase, authenticate with a token. I'm going to compute a wake-up time. This is setting an alarm earlier in the evening. Set the timeout for when I should set my target temperature, and pick a target temperature. Usually this is presented in the UI of the integration we're doing. This call is a little bit different. This is not ref.on, this is ref.once. So Firebase also allows you to just get data once and process it. This won't be called every time data changes. This is just called the first time. And this shows how you would walk through all the thermostats in a structure. So for each thermostat, set a timeout to change the target temperature at the time I'm going to wake up. Pretty straightforward. The last one we have is LIFX. This one is using the Nest Protect APIs to respond to changes in alert state. When it senses smoke, it can change the lights to blink red, which gives people better visibility in smoke, and also provides visible cues for people who are hearing impaired. So again, this will look really familiar for the first couple lines. Oh no, it changed. Look, here we're going to set up some functions to set lights and blink lights, but now it looks familiar. So we connect to Firebase, we authenticate with our token. All right, there's more code. Here we call once again, and we're going to walk through all the smoke detectors in a structure. And here we're actually going to say for each smoke detector, I'm really just interested in the smoke alarm state. So set my callback just on that one. I don't care when battery level changes. I don't care when CO changes, although we probably should blink lights in that case as well. But this shows that you can listen to specific data elements in this document and not have to respond to the whole thing. And here I basically say if it's warning, why don't we blink the lights yellow? If it's emergency, set the lights to red. If it's all clear, set the lights back to white. So there's 4 integrations. Somebody who's not very good at JavaScript was able to whip this out in 30 to 60 minutes total. I actually ran them in a browser and they worked. But they're pretty compelling use cases, we think, for integrating with data provided by Nest devices and really, really extending the reach of what we can do with a more responsive home. Next, we'll get into user interface. We have a detailed section on UI guidelines on developer.nest.com, and we'll just touch some high points here. We don't want you to build Nest apps. We built those. We think they're pretty good. We'd like you to build your apps based on Nest data. The only things that we ask you to respect are there's a few key things. Home and away are very critical concepts, and so we prefer that those stay home and away. And Nest protect event states, like we talked about. Those are security things, safety things. We don't want to confuse users in the case of an emergency, and don't try to be too cute with the house is on fire. There's also a list of trademarks, logo usage, et cetera, et cetera. There's a whole page on it at developer.nest.com. When you get ready to launch, I suggest going through that. Testing. Nest devices are really, really simple from a UX standpoint, really, really complicated for the kinds of hardware they actually have to work with. And we touched a little bit on the complications of HVAC systems earlier. But when we were thinking about this, if we hand developers a physical thermostat and say, why don't you test all the corner cases, you're going to have to wire the back plates to like 75 different combinations of has cool, has heat, doesn't have cool, has a common wire. So we've created a Chrome extension that allows you to create what we call virtual devices. And the capabilities of virtual devices are extended to allow you to physically modify the wiring, not physically, virtually modify the wiring of the device. So I can create my fake device, I can set it up with an air conditioner, run my tests, I can take away the air conditioner, which on the actual thermostat would be the equivalent of pulling it off the wall and removing a wire, which allows me to test a wide range of permutations of hardware without having to set up a really crazy test lab. We also have measures in place to protect both the devices and the service to make sure they're available for everybody all the time. And so we have two different types of rate limits. The first set of rate limits are designed to protect devices. Our devices are highly constrained. They're stealing power from the HVAC system at really, really low current levels. And so you can't make an unlimited number of modification requests to thermostats and expect them to continue to function. So when we think the device is getting into a state where it may not be able to execute all its functions, we'll start rejecting developer requests. So if you see something that's a 429 response or an error code in Firebase that says device can't service this at this time, it's time to back off. These rate limits, because they're protecting the device, are shared across all client integrations. And so this is a little bit different than a lot of the ways rate limits work. If a customer has 100 integrations and each one's making one request a minute, a lot of them are probably going to get rejected. The second set of rate limits we have are to protect the service itself. And these are per client or per access token. These are typically around the REST API. We do have a limited number of modification requests you could make. Those are device specific. But for GET requests on the REST API, each connection that's established burns a little bit of CPU and bandwidth. And so we limit you to a reasonable number of requests per access token. The nice thing about Firebase, because it's a long-lived connection, is you're effectively unlimited for read requests because you should establish a single connection and just let that ride for a pretty long period of time. So we encourage you to go that way. Things to look out for while you're testing. Cover the expected cases. That includes things like users have multiple structures. You should let them pick which one you want to turn the lights on in, probably. Users may have multiple thermostats per structure, although a lot don't. Users may have multiple Nest protects. And like we talked about before, the thermostats themselves have a variety of wiring combinations that provide, some have fans, some have air conditioners, some have heat pumps, some have stage 2 heat pumps. But you should test as wide a range of permutations of physical hardware as you can using the virtual devices. Also, make sure you handle the unexpected. So network connectivity gets disrupted, clients disconnect, clients reconnect. Make sure you take that into account. Rate limits can occur. We don't have a fantastic story for simulating rate limits, but if you do get a 429 response or rate limit, make sure you handle that appropriately. Once you get above a certain size, we do have a lightweight client review process in place. And this isn't to stifle innovation. This is just to make sure that once people get above sort of mass market size, that we have some review that people are meeting UI guidelines, that the thing actually works, that it's not totally detrimental to the Nest service. This is the token cap request that comes into us. We look at things. If it passes muster, then we up your token limit to however much you need. As Matt covered before, all of this stuff is available right now at developer.nest.com. You can go there today. We have many, many developers already signed up. You can create an account. You can create your clients, provide the scopes you need and the justifications for those. There's a detailed set of documents on testing. There's guidelines for deployment. And there's also forms to go request more tokens when your app gets above a certain size. The documentation we provided is pretty extensive. We've worked with a lot of people for reviewing this. We've done a lot of work internally to have people inside Nest come try to build integrations on the Nest platform. So we think what we have is pretty good. There's a ton of it there. If you don't get your questions answered there, we also have the Stack Overflow Nest API tag. We'll be happy to answer any other questions. Thanks, guys. I'm going to hand it back to Matt to wrap up.
Thanks, Mark. Yeah, pretty excited to be here and pretty excited to see what you guys are all going to do. And as you see, like, we put together a pretty comprehensive program. There's a reason why it took us, the better part of 8 months to get here. We wanted to think about the whole end-to-end experience, think about authentication, about user privacy, about being transparent. I think we may be one of the first companies to ever do this. Everyone uses OAuth, but most of the time when you use OAuth, it says, hey, this app wants access to your contact list. And well, why does it want that? So I think putting the extra mile and having developers say what they want to use the data for, I think gives users that additional comfort about their privacy. And I encourage everyone to be honest and open about this because we're going to be auditing it too. So again, everything, as Mark said, is available on developer.nest.com. We went through kind of extensive review internally and with our early beta partners to make sure we have a really comprehensive set of documents for you guys to use. Big and small. Anybody can work with Nest, any platform, iOS, Android, web, hardware, software services, the whole gamut. No hardware changes required, and you guys can start today. Again, summing it up, thermostat control, working with Nest Protect and listening for those alarm states, home and away, ETA. I think these are really powerful concepts, and I'm really excited to see what we do. I mean, this is just the beginning for Nest. There's going to be hopefully thousands of applications that we haven't even thought of, and things you guys are going to build over the coming year. Really excited to see what you guys all do. And again, this is just the beginning. I can see this being a platform that we use and we leverage. As we add more products, what other cool features can we add? Again, thank you all for being here. I really appreciate it. One last thing. So we had a long history getting to where we are. And like Nest is doing really well, and being part of Google has been amazing. But getting here was a long road. And I can imagine for a lot of you guys getting started, you don't necessarily have all the networks that we had to get started. So thinking about that, my co-founder Tony and I were talking about, well, how can we make this program completely comprehensive? So we partnered with some of our early investors, Kleiner Perkins and Google Ventures, to create a fund for Nest developers. So that as you guys are building your apps, if you think you need funding to build your company, that's available. And applications are online, thoughtfulthingsfund.com. And the KP and GV guys are going to check it out and start funding companies that work with Nest. So I think it's a really good thing. I think it's one of the first times this has been done in the home. So really excited to see what kind of new companies come out. As I asked earlier, there's a lot of things that could be built and a lot of companies that could be started in this industry. So thanks again for coming, and really excited to see what you guys build.